What is happening, guys? We are back after quite a while. Sorry about that absence there. So, we are making a bit of a pivot on the channel from motion simulators to motion replicators. So, this is Cagliari Mini Moto GP, something of that nature. It's got a little 50cc motor on it. I've had it for, I don't know, 8, 10, 12 years, something like that. Can't remember. Very long time. It has seen better days. I've done a whole bunch to this motor, including a rocket key to advance the timing on it by 5 degrees. I've put a new clutch with a third bearing on there to support the sprocket and chain, because it has a tendency to want to pull it this way, which loosens the chain and causes issues. Upgraded the exhaust at one point, but it wasn't any good, so got rid of it. It's got carbon fiber reeds on the intake side. I want to say I upgraded the carb at some point, but it looks like I went back to the original. So I did upgrade this motor quite a bit, but kind of pushed it as far as I could go, aside from getting a big bore kit, and those are expensive for very little payoff for them, essentially. So what I ended up doing was I bought two pit bikes with larger motors. This one here is a 70cc, and then I have another one in here that's a 110cc with the exhaust and parts that came on there. Oh, my Google base. What do you mean me on for? So the game plan was to take this 70cc motor and put it on that Cagliari. The problem is, I'm not sure if you could tell in this video, this is essentially eye level with the Cagliari, and then that's eye level with me standing up. So it's quite a distance to stand up for me, essentially. The handlebars are 18 inches off of the ground, essentially is how it looks. So it's 1.5 feet off the ground. It is very, very tiny. When I ride it, I look like a bear riding a tricycle in the circus. So this big 70cc motor, there's no way it'll ever fit in that frame. Like, without extending the forks and swing arm, like, it's just too small. It won't fit in there. It physically won't fit in there. So that's when I kind of scrapped that idea. And then I put those motors inside of this tote and just like left them there for 5 years, 6 years, something like that. And so I've got these two dirt bike frames that I've had for those 5 years, because these are the dirt bikes those motors came off of. This one had the 70cc motor, and this one here had the 110. This one is a much bigger frame. It's got bigger tires, bigger forks, better suspension, everything, but it's still very small. So if I ever do this one up, I'm gonna make it bigger. I'm gonna extend stuff and just make it a larger frame. This one's like as stretched as a frame can be for a pit bike, is essentially, which is why this one is actually taller than this one. But anyway, it doesn't matter. So I started looking into building electric dirt bikes and electric drift carts and stuff like that online. Saw that it wasn't too terribly difficult, especially with my motion simulator knowledge. I figured that this wouldn't be too bad to tackle. So when I started looking into this, let me shift my hands around, get that hand out of the camera there. It's going to be in the camera, doesn't matter. So when I started looking into this, I got a 3,000 watt My 1020 motor with its little motor controller, and then I got this battery in here which is a 72 volt, 30 amp hour battery, LiPo battery, but it only has a 50 amp BMS. So basically that battery will only output like 3,600 watts, which was going to be fine with my 1020 motor. The problem is, the more I looked into the my 1020 motor, the more I saw people just weren't very pleased with it, and they were trying to push it harder, and it was overheating. They had to do modifications. It just didn't look like the motor for me, basically. So they never charged me for it and never shipped it out. So I canceled that order and then ordered a Kunray KRV5 or KR5V, sorry. And I'm still waiting for that one to ship. I wanted to do this video once I at least had the motor controller, and the battery, so that way I could, start mocking this up and start actually building it, and that would make a better video. But I just decided to go ahead and start this video because more components arrived, and I wanted to show you guys those. So got this battery, like I said, 72 volt, 72 volt, 30 amp hour, 50 amp discharge. So 3,600 watts. So when I upgraded to the 5,000 watt motor, that battery is not going to be able to cut it. It's only going to be output, 3,600 watts comfortably. I want to say I saw that it could maybe peak to 75 amps, but I'm not certain. So if it does, then great. That'll give me a bit more power. But the more I looked into it, to get powerful batteries, like the peak power for the KR5V is 10 kilowatts, 10,000 watts. So I was like, all right, well, at the minimum, I would like to get a battery that has the ability to output that, so I can at least see what 10 kilowatts feels like, because that's like 12 or 13 horsepower. So it's fairly decent, especially if you're on a tiny little bike like that. That'll get you moving. So the more I looked into it, and I was like, man, if a 3,000 watt battery is already $400, like 500 after shipping and everything, then it's going to be crazy expensive for good batteries. And realistically, I wanted like a 20 kilowatt battery, 30 kilowatt battery, 40 kilowatt battery. Like, I know the KR5V won't be able to handle that, but I wanted a really good battery. So started doing research and just decided I'm going to build my own. So I got the cell holders and their layout. And then today, all of these came in. These are the Ampace JP40s. These are 21700 cells, 3.7 volts. They're listed at 70 amps. But they can pull 45 amps without reaching thermal cutoff, I believe, until discharge. So they're 45 amp continuous discharge without thermal cutoff, and they will peak at 140 amps for 5 seconds. So I'm running these in a 20 by 10 configuration, a 20S 10P setup. So 20S will get me to 74 volts or something like that, just over 72 volts. And then the 10P will get me, these are 4,000 milliamp hour cells. Each one of the 2170s is 4,000 milliamp hours. So times that by 10, that'll give me 40 amp hours, because they're essentially 4,000 milliamp hours is 4 amp hours. So 4 amp hours times 10 is 40. So that'll give me 40 amp hours. And then if they're rated for 70 amps, then 70 times 10 gives me 700 amps. I'll probably not run it at the 700 amps very often. And then obviously, if I want to run it at the peak for 5 seconds, I can run that at 1400 amps. But I got the BMS that I got with this is an amp BMS. It's a 24 cell BMS, so I won't be using for the cells on it. But it will do 420 or 440 amps continuous, and it'll peak at 1,050 amps for 10 seconds. So out of the 1400 amps these will produce for 5 seconds, I can use 1050 of those amps for, let's say it won't be 10 seconds. The BMS will handle 10 seconds, but the cells won't be able to handle that for 10 seconds. So we'll say 6 or 7 seconds. And that will get me essentially 72 kilowatts, somewhere around in there, which is like high 80s, low 90s horsepower. That's ridiculous. But this thing will more than likely be rated for 42 kilowatts. Well, if I only pull 600 amps across it, then it'll be restricted to 42 kilowatts. I am still waiting for the copper nickel bus bars to get here. I had to order those from China. And those will essentially be the things that will connect the cells together and connect one bank of 10 to the other bank of 10, right? So like this first one will be positive, so it won't be connected to anything. It'll just have one plate on it that goes out as a positive plate. Then there'll be separation between this row and this row, and then this row and this row will be connected with a plate, and then there'll be separation between this row and this row, and then this row and this row will be connected, and then on the bottom end, this row and this row will be connected. There'll be separation between this row and this row and this row will be connected. So it'll basically be put together kind of like an accordion, but with the cell holders, it won't be able to move. And then I'll be able to stack the boxes on top of each other or side to side, however. But I won't have to have it won't have to be, a battery that's going to be that long, and then it'll be as tall as those batteries inside the cell holders, plus the BMS, plus all the tape and whatever dividers and stuff I put on there. So I don't want it to be necessarily long. I'd rather it be stacked and tall, so that's what I'm going to do, and that's why I got the copper plates to be able to facilitate that. Problem with the copper plates. You can get the copper plates in different thicknesses, and those thicknesses will determine the amount of amperage you can carry across them. So the first set that I ordered, that should be a problem statement in and of itself. The first set that I ordered was 0.3 millimeters thickness, and I was going to connect, this set as one pack and this is one pack. And then I was thinking inside my head, for whatever very dumb reason, I was thinking that I would leave them as two separate packs, and then I would actually try and series them through the wires and the connector itself. It doesn't make sense. Like the more I thought about it after I realized it doesn't make sense, I couldn't even figure out why I thought it made sense in the first place. So that hurts my head. Basically, when you series something, the power from this one has to go through this one. It doesn't matter how you assemble, it doesn't matter, but the power from this brick has to go through this brick. All of the power that's going to flow through all of these cells is going to flow, and it's going to flow through the substrate of this brick, which will be the copper. So the 0.3 copper that I ordered will only handle 200 amps. So that means that it'll only handle 200 amps across the entire battery. The battery will only be able to supply 200 amps. Well, this thing's capable of supplying 700 amps up to 1400 amps for 5 seconds. So that's not going to cut it. I wouldn't be able to push the battery. If I did, then I would risk melting the copper, and if the copper melts and connects on the battery and then shorts it out, and you got a lithium fire and all the cells go, and oh my god. So that would immediately torch this $625, $675, I can't remember. But that's how much just the cells alone cost. Was like $625 or $675, something like that. So the first set of copper that I got was not going to work because it's 0.3 millimeter thickness. That'll only handle 200 amps. So I got back in touch with the seller on eBay and just told them, hey, they literally just shipped out my 0.3 millimeter order. And so this time I actually talked with them and asked them a bunch of questions to figure out, if I ordered the 1 millimeter thickness, would I be able to spot weld the nickel onto the tabs? Because if you increase the thickness of the copper, you're going to also have to increase the thickness of the nickel to transfer the power from the cell to the copper itself. So, oops, there we go. So in order to weld the nickel onto the top of these tabs, you have to do it with a spot welder, because you don't want to put a ton of heat into these cells because you'll destroy the cells. So you can't solder, I mean, you can, some people have tried, but you can't solder something thick onto there, because it's going to require too much heat. You're going to have to put too much heat into the cell and that'll destroy it. So that's why you need a spot welder. It looks kind of like a voltmeter. It's got two little prongs. You'll put the two little prongs on the cell. You'll put the nickel on top of the cell, and then you put the two little prongs on there, and then electricity will flow through, zap, it'll weld those 2 points onto the battery where these two probes were touching. So then the nickel will be stuck to the battery. But they get progressively more expensive. The more capable the spot welder is, it gets exponentially more expensive. So I bought like $100 spot welder on Amazon. Nothing super fancy, but still not a $20 little handheld crappy one. So I had to go back and forth with the dealer in China to find out how thick the nickel was, if it was going to be pure nickel, if how much amperage could the 1 millimeter carry versus the 0.3. So basically, got all the answers I needed, figured out that it was going to be possible, barely, but it should be possible. And the 1 millimeter should be able to carry like 700 amps across it without really breaking a sweat. Or 600 amps, let's say, really without breaking a sweat. But it should be able to handle like 1,000 amps for like 5 seconds. So I went with that, got that ordered last night or the night before. Can't remember, but that's going to take like 2 months to get here, a month and a half to get here. So it's going to be a very long time waiting, and in the meantime, I need to make sure that these cells, oops, I might keep coming up the mic. In the meantime, I need to make sure that these cells don't discharge, because they have a habit of doing that. While sitting, they will just discharge, and they do it unevenly. According to the couple of videos I've seen of people building batteries with these cells. So I gotta be cognizant of that, and if that starts to happen, then I gotta get a 21700 battery charger, cell charger. But that's like $20, so that shouldn't be too bad. And hopefully I've got to pay real close attention when I get it, because if I overcharge one cell, then I'll have to either charge all 200 of the cells up to that rate, or I'd have to discharge that cell to get it to the same rate as all the other batteries. But essentially you need all the batteries to be at the same rate when you actually put them in here, and then especially when you start welding the bus bars onto them. So that is what we're doing next. We're waiting for the motor. Like I said, they still haven't even charged me for it, so they haven't shipped it. I don't know when that's gonna happen. I might cancel that order with Amazon and just get the motor from somewhere else, because I'm tired of waiting. But once I get the Conray KR5V, then I can start getting that mounted down here, and then this battery that's in there is already charged up, ready to go, so that'll get mounted up in there and then get connected, and then the controller will go up in there. I might cut the tank or something, but just to get that set up. And the reason why I'm doing it on the dirt bike is because I have them. If I had a go-kart, I would be setting this up on a go-kart and building a drift cart, but I have these dirt bike frames. I I've got four. I've got, well, not dirt bikes, but I've got this dirt bike frame, that dirt bike frame, that tiny little pocket bike frame, and then back behind the house over there, I have another super pocket bike frame. But I don't think I have anything else for it. Pretty sure I lost the forks. They're not in here. And the swing arm. And I don't know where all the pieces to that bike went. I think they got thrown away. But I got the tires for it right there. And then plastics and crap. But so that is essentially what the next video should be. It's gonna take a while. Like I said, the next video will be me getting the Conray fit into this and working. I got new tires for this, I got new plastics, I got new bearings, a whole bunch of stuff to make the bike actually work is all in those boxes. And then changing it, it's got a 420 sprocket on there, changing it to a T35. So I got a chain and an 80 tooth T35 sprocket for a Manco that we have to adapt for that hub. And new brake lever, because this is frozen and I don't want to deal with that. Might have to get a new caliper, so that might also be frozen because this has all just been sitting in water. So keep an eye out for the next video, and we'll see if we can't get her built and see how she runs.